Добрый день, меня зовут Ребекка Stambler. Я хотела делать доклад сегодня по-русски, но я решила не мучить вас моим ломаным русским языком. Так что now I'm going to speak in English. So I code in Go every day, but I always feel like I'm fighting with my editor. It's often very difficult to get it to work correctly. A lot of times I'll try to do something like jump to the definition of a variable, and I get a confusing error message. Or I'll try to find the well, that's expected. Or I'll try to find the references of the same variable in a small file, and it'll take several seconds, and I'll be waiting forever for some limited results. Or I'll try to upgrade my editor extensions, and I'll see this delightful error message that I don't understand. So in moments like these, I just want to yell at my computer, Go, please stop breaking my editor. So today, I'm going to speak about why it is that your editor is always broken and how we're going to fix it. But first, a little bit about myself. I'm an engineer on the Go team at Google in New York City, and I've been working on Go tools and editor support for the past few years. So at this point, I've probably tried every single editor that supports Go. But most of these editors just don't have all of the features that I want. When I'm coding, I really want to be able to see the build and vet errors in my code as I'm typing. I want to get auto-completion so that I can type faster. I want to get signature help in case I forget the parameters to a function. I want to be able to hover over variables and see their type and then be able to jump to the definition of those variables. And I want to see an outline of my document so I can see what types I've declared in my code. But most of the editors that I use just don't have all of the features that I want. I can tell you for a fact that a lot of people on the Go team don't even use auto-completion because it's too difficult for them to figure out how to set it up. So why is the Go editor experience so flawed? Why does everything seem to be broken? And why does it break? Well, the first reason is pretty simple. There's just a lot of different editors and a lot of different features that they all have to support. It can be really confusing to manage because every editor works in a slightly different way and has a different set of features. As of the Go survey in 2018 that just came out, the top editors for Go are VS Code, Goland, and Vim. So if you use one of those three editors, you probably have a pretty good editor experience. But if you're in the minority of people who uses Emacs or Vim Sublime or Atom, your editor experience will be pretty challenging, and it will be difficult to configure or to figure out what extensions you should install. So what you want is to have these features on by default rather than to be searching for the different things to configure. And the next problem is that even if you have all these features, sometimes they can be really slow. And you might experience a lag that is so noticeable that you just turn off the feature entirely. And finally, even worse than being slow, you can find that these features don't work at all. And that's because new Go releases tend to break them, and because of the changes in the Go build system. And if there's no maintainer for the feature, then it will just stay broken. So this all sounds pretty awful. It sounds like it's going to be really difficult, a difficult problem. But I promise that we can fix it if we just identify all of these issues and try to come up with solutions for them. So in my talk, I'm going to speak first more in depth about the different problems, and then I'll go into the ways that we're going to fix them. So the first problem that we mentioned is that there are too many different editors and different features. It's too difficult to manage them and figure out which ones you need. So to understand why it is the case that it's just too many different editors to figure out and different features, we're going to discuss more in depth about how editors actually work today. So we'll take an example. I'm a user, and when I'm coding, I really like to jump to the definition of an identifier. So I'm coding, I right-click on my variable, and I click Go to Definition, and we'll say that I'm coding in VS Code, and we'll take that as an example because it's a really popular editor with a really good Go extension. And so my request gets propagated to VS Code and to the Go extension. But the Go extension itself doesn't contain the logic to figure out the definition of my variable. Go extensions are written in TypeScript, or VS Code extensions are written in TypeScript, and I don't have to tell you that it's not fun to analyze Go code using TypeScript. So instead, what the extension does is it calls out to a command line tool called godef. And godef is written in Go, and the Go standard library has a lot of great APIs for writing Go tools and for analyzing Go code. So godef is a command line tool. You could, call it on the command line just by writing godef x. And it has its own input format and command line interface, and then it outputs a result that is propagated back to VS Code, and VS Code can understand that result. And then VS Code opens your file at the correct position. So this all seems quite simple, but it becomes very complicated when you think about all of the different features that VS Code actually supports. So every one of these features is provided by a different Go tool. Every feature has its own command line interface, its own input and output format, and each tool is written by and maintained by a different person, or by a different group of people, or by no one. So you may not have realized, but when you installed the VS Code extension for Go, you also installed 24 different Go tools. And now let's add in all the other editors. It becomes really tangled and confusing and difficult to manage. So to solve this problem, we need to make it easier for editors to pick the features that they want and to support them without having to use a Go tool for each different feature. So we covered our first problem, number 1. So now we run into the issue that many of the features that editors provide are actually quite slow. They don't work very well. So why is that the case? Well, as we were discussing with godef, most of these tools, the majority of them, are command line tools. So they work in the exact same way. Basically, VS Code sends them a request, they process the request, and then they send the response, and the process exits. So they only ever handle one request per process. That means that they have to do a lot of extra work over and over again. It means that your tool has to read your file, parse it, type check the code, and type check all of the dependencies. And that's happening every time you call jump to definition. And that works fine for a simple example. But if you have a large project with a deep dependency tree, you can be waiting for multiple seconds for something like find references. So that is the pretty simple answer of why editors can be slow. They just have to keep redoing extra work. So to solve this problem, we need some sort of shared infrastructure so that tools can run persistently and cache their results, and we need to be able to share the results between different tools. So now we move on to our third problem. And that was that sometimes our tools are just broken. And that's because new Go releases often break tools. And so the features are broken because the underlying tool is broken by the new Go release. So to understand more about why that happens, we'll talk about an example. And it'll be an example of a tool that has broken over a number of the past Go releases. And so the tool that we'll talk about is Go code, which is the tool that's used for auto-completion in the majority of editors. It comes default with VS Code and a lot of others, except for Goland. So if you're using auto-completion in your editor, you are probably using Go code. And Go code has worked really well for many years, over many Go releases, and hundreds of thousands of people have been using it. And it's also, before I get into it, worth noting that the person who wrote Go code was a member of the Go community and not somebody who is paid to work on Go tools. So people who share their work this way have no obligation to continue maintaining their tools forever, and the Go team has a responsibility that if a tool is really popular, we should continue to maintain it and to help support it. And in the case of Go code, the Go team didn't really do a good job of that. And as a result, Go code became a pretty good example of a tool that broke over a few Go releases, and basically it illustrates the problems of having a tool that hundreds of thousands of people rely on that only has a single maintainer. So everything worked really well until Go 1.10 came out. And Go code broke with Go 1.10 because a build cache was added to the Go build command in 1.10. And this change was just incompatible with the way that Go code worked, and so it was just broken. And everyone's auto-completion broke when they upgraded. But fortunately, an engineer on the Go team actually completely rewrote it and forked it into his own repository. So, okay, the problem is solved. Well, the experience for users was still really bad. Basically, you had to realize that your auto-completion broke when you upgraded. Then you had to figure out that the broken tool was Go code. Then you had to go and find the issue tracker for Go code and find the issue that told you what new repository to switch to. And then you had to upgrade your configurations so that you were actually, to make that change. So there was a lot of upheaval and confusion and just in general a bad experience for users. But hey, at least it's over, right? Of course not. In Go 1.11, we released modules, which are the package management system for Go. And this was another fundamental change to the Go build command. So it caused all of the Go tools to break again. And this includes Go code. So the Go team really wanted people to try out modules, but it's pretty difficult to convince someone to make the switch if it means, oh, you can't use auto-completion anymore. So I ended up forking Go code into my own version that fixes it for modules. So now VS Code decides between 3 different versions of Go code, depending on your Go version and if you have modules enabled or not. So overall, a pretty unpleasant experience for users. And basically, at this rate, we're going to have a version of Go code for every version of Go. This isn't really sustainable. And it's also just really unfair to users because your tools should not constantly break, and you shouldn't have to go digging through the issue tracker just to figure out that your favorite tool is broken again. And it's also very unfair to the people who write tools because there's no reason for you to write a tool if you know that it's going to break and the Go team won't tell you that it's going to break and there's no one to help you maintain it. Basically, right now, if you write a Go tool, you're signing up to maintain it forever, and that's not fair. So we need some way to fix this problem, but we still haven't really discussed the problem. Why did it keep breaking? Why do Go releases break all of the tools? So it intuitively makes sense that if the language changes, then your tool that works on the language should also change. But modules aren't a language change, they're a build system change, and same thing with the change in Go 1.10. This isn't a change in the language, And Go has been pretty stable over the past few releases. I don't think we'll see any major language changes until Go 2. So it's really a problem that when the go build command changes, then tools also have break. And so the tools have to change because tools depend on the way that the go build command works. Every Go tool basically has to act like a little Go compiler. It has to read your files, it has to parse them, and type check the file and all of your dependencies. So basically, every Go tool begins the same way and begins with the same few hundred lines of code that do all this reading, parsing, and type checking. And so basically the way that it works, and the reason that it depends on the way the go build command works because we'll go through kind of an example. Basically, tools start at some file that you, the user, are coding in. You're coding in some file foo.go, and you want to get some relevant type information for that file. So you have to figure out first, what package does this file belong to? Well, okay, I can look at the top of the file, see the package declaration. I can take a look at the directory that I'm working in and see, okay, my package, I guess, is probably this one, even though this is all sort of guesswork and assumption. And then, because you need to know the dependencies of your package, again, you can look at the import list, and you can find the dependencies, and you can guess that they're probably located in the place that Go build expects them to be. So in essence, you are reverse engineering the behavior of the Go build command. And if you upgrade to your Go version to the latest version, and your Go build command has changed and dependencies are now located somewhere else, then your Go tool, which maybe didn't upgrade, doesn't understand how your code works anymore, because your Go tool still thinks it's in Go 110, but your Go code is written for Go 111. So if you're using another build system like modules, or like dep, which was the precursor to modules, then your tools just will not work. And in the past, you've had to write specific logic into your tool to make it work for tools like dep or GB, another build system. Basically, every tool had a little bit of code that would decide, oh, am I actually using dep? Okay, then I should find my dependencies in this other folder. And that's really annoying because if you have 24 different Go tools, they all have to understand things about the dep build system or modules. So it's really unsustainable. Ultimately, to solve this issue, what we want is a way to write that code one time to understand dep, and then be able to kind of reuse it for all 24 different tools. So I think now we kind of discussed all of our many problems, and it's time to start coming up with some solutions. So I've shown you all of the different ways that your editor isn't working, so it's time to fix it. And how will we do that? Well, the first thing we have to do is fix that issue that we saw with Go code. We need to stop Go releases from breaking tools every 6 months. So we need tools that are more stable and easier to maintain. And second, the Go team needs to commit to supporting a set of features that will work well for all editors. We need features that every Go developer needs to work. And so, just like with the problems, we'll go through each of these solutions step by step in depth. So the first problem is the one that we saw with Go code. And the Go team actually worked on solving this back when modules came out in Go 111. So the Go tools team was asked to fix all of the tools that broke with modules, and that was a lot of work, and we decided we didn't want to do it again. So we came up with a layer that would work between the tool and the build system beneath it. So this would be a way to write your tool and have it work no matter what system you're actually working in, or whatever version of Go. So let's imagine that we're rewriting Go code, but we're using this new API, which is called Go packages. So we're going to rewrite Go code, and we start again from the same situation where we're coding in a file, and we want to figure out what package that file belongs to. Before, we would have tried to make some guesses based on how the go build command works. But now, we're just going to ask Go packages, because Go packages has a way of communicating with the underlying build system and the Go version and figuring out how to get the correct answer. So Go packages thinks, okay, what build system am I running in? What version of Go am I using? And it communicates with an underlying driver. And so this driver could be for the Go build command, or it could be for another build system like GB. And it communicates with the driver and asks it for the package information. So what package does this file belong to? And because the driver is specific to the build system, it knows exactly how to answer this question. And so it responds and gives us back the answer. And so this significantly reduces the maintenance burden of writing a Go tool, because now your Go tool doesn't have to worry about the build system. It just has to, basically we've replaced 100 lines of parsing, type checking, and figuring out dependencies with one line to function call packages.load. And so it also simplifies the whole process of upgrading to the next Go version, because instead of fixing the tools in 24 different places and making sure that they understand the new version of the Go build command, you just have to make the change in one place, in the driver. This basically allows our tools to become a lot more stable because they know how to communicate, because they have a layer that lies between the tool and the build system. So the next question that we need to answer is, how will we make our tools more usable? We've made them more stable, but now they actually need to become easier for users to install and configure and figure out what tools they need. And so we need some common set of features that all editors can commit to providing and that the Go team will commit to supporting. So how do we choose the set, and how do we manage it all? Well, fortunately, somebody has already thought of and figured this out. So the language server protocol, or LSP, is basically a standard for communicating between the editor and the language server. The language server here is basically the same thing as our Go tools. The only difference is that it is a persistent server that has a core set of features that it supports, rather than a single tool per feature. And it basically speaks a common language with the editor, and the editor sends it questions, and the language server responds. And so the language server protocol will allow us to change this picture into this one. Instead of having a bunch of different tools for each feature, we have a single language server. And all your editor has to do is figure out what language is this file written in, and then it knows which language server to route your request to. And so this really levels the playing field for all editors and for all languages. Now, all a language team has to do is write a language server, and then they support all LSP-compatible editors. And all the editor teams have to do is support LSP, and then they support all the languages with a language server. It really simplifies life, and also the protocol defines a core set of features that include all of the ones that I showed earlier, as well as many other. And it's constantly evolving and growing, so more features are being added. So at this point, I think it's pretty obvious where this talk is going. So for the past few months, my colleagues on the Go team and I have been working on a tool called gopls, which is the language server for Go. And it's built on top of the Go packages API, so it will work for all build systems. And it's built on top of LSP, so it will work with all editors. And our mission is just to provide great editor support for Go. The Go team is committed to owning and maintaining the gopls, but we're also developing it in collaboration with the larger Go community. And it's also currently in alpha, so I encourage you to try it out after the talk. And yes, it is pronounced go please, even though everyone thinks it's pronounced gopls. So in general, go please will be a lot more stable and a lot easier to use, but it will also work better. And the reason for that is that it will be a lot faster than previous Go tools. So before, when we talked about GoDef, we talked about how every single tool had to do all the parsing and type checking again every single time it was called. Not the majority of tools did this, not all. But GoPlease is a persistent server, so it benefits from caching. And we can just cache results and reuse this type information over many requests. And this really causes a significant increase in speed for Go tools. In the past, Go tools, some of the Go tools that require high speed were pretty fast. So Go code was already below 20 milliseconds often for auto completion. But with GoPlease, completion is often instantaneous. So you'll feel a noticeable improvement in speed with it. It can often be less than a millisecond, and the same goes for the other features as well. But in addition to that, a common complaint with the release of modules was that all of the Go tools became really, really slow. And GoPlease, because of the caching, is able to remain fast even though it works with modules. But in addition to speed, GoPlease will also be better because it will be easy to extend. Before, if you wanted to add a feature to your editor, you would have to write your own Go tool. You would have to send a pull request to your editor extension and ask them to incorporate your tool, and it would take a while. But now, with GoPlease, adding a new feature is as simple as adding a new function, and of course, a test. So you don't have to worry about all that underlying infrastructure of the parsing and the type checking. All you have to do is write your feature-specific logic, because all that infrastructure is already written, it's already there. And because of this, because it's so easy to add features, we plan to add a lot more. We currently have a pretty basic set of features, but we are working on, there's many that the community are requesting, so we're working on a lot more features. But I'll just give you an example of some of the features that are upcoming, that are next on our list. So we don't yet support references and renaming, but that is the next priority. And we're also going to add support for additional diagnostics. So you saw that we had Go build and Go vet errors as part of GoPlease, but we will also be adding lint errors, and we also want to add support for custom diagnostics. So if your company has some checks that it runs before you submit code, we can plug that into GoPlease. And also, we're going to be working on quick fix suggestions. So if you have an error in your code, we can pop up a box and you can accept the fix. These are just a few of the next features you can expect, but we're also listening to the community and hoping that people will request features, and we will be listening to the community and trying to add the features that are requested first. And of course, you can always file feature requests on the Go issue tracker. And finally, GoPlease will be better because it'll be more reliable. One of our main priorities with GoPlease was making sure that we had a good set of tests, so that it would be easy to add new tests, and our tests would have good coverage. In the past, if you wanted to write a Go tool, it was pretty difficult to write tests because your tests end up being actual Go code. It kind of feels like Inception. So most of the time, people would either write no tests at all or just very rough tests that didn't have enough coverage. So one of the first things that we did with GoPlease was write a testing framework that would allow us to test a lot better. And because GoPlease is part of the Go project, it'll run against the Go try bots, and so when something breaks, you can come yell at us. And so in the past, Go developer tools have been written by an individual, and if that individual didn't have enough bandwidth to fix your issue, it might go overlooked. But now you have an entity that is behind this project, and we're committed to supporting it. So even if I leave the Go team tomorrow, Go Please will still be working. And finally, Go Please will be better because we're developing it with a lot of collaboration from the community. I honestly don't think that we would have started this project if it hadn't been for so many requests from the community members. So we've really worked closely with people. We've actually had a Slack channel where people can ask us questions directly and just generally discuss things. And we also have regular video conference meetings for more in-depth discussion and general collaboration and demos. So in this way, we've been able to get a lot of input from community members and make our talks work really, make our tool work really well. So finally, I'd like to end with just a little bit of information. All the status updates and general installation details can be found on the Go Please wiki page. And the information on the Slack channel and the video conference meetings that I mentioned is available on the Golang Tools wiki page as well. So please check those out. We really hope that you try out Go Please, file issues, send us your feedback, and talk to us in general on Slack and on these meetings. So thank you very much.
Друзья, у нас есть время на вопросы.
Hello, Rebecca. Thank you very much for your talk. Hi. I was also contributing a bit in the fork of the Go. First was a fork of Go language server by previous implementation. Maybe you know Bing. He forked it and later improved it and released as a bingo tool. And right now he's deprecated the bingo. He forked Golang X tools, basically tools repo, and implemented some of the features which you mentioned, like rename, references, and he's trying to maintain the fork. So Bing/tools. Did you discuss the merge with him? Because right now most of these extra features are working pretty stable. And what are the current plans to integrate? Maybe it will speed up things a little bit. Thank you.
Yeah, so we actually have communicated with Bing about Bingo, and we wanted to collaborate. The issue is that he's in China, so it's pretty difficult to contribute to the Go project from China. You have to do GitHub pull requests. But we talked to him, and the reason he deprecated Bingo was so that basically he wants us to support one language server that's written for Go. And I think he actually put a comment on his page that he's hoping for us to, basically for Go Please to be the source of truth. And I think we'll probably, if he wants to send us pull requests, we'll accept them, and we're going to try and make sure that we basically get the same features that the fork has, and then hopefully it'll just be merged, basically. So I don't know if we'll take the features directly, but if he wants to contribute pull requests, we hope to collaborate with him for sure. Yeah.
Вопросы? Можно по-русски, я переведу.
Hi, Rebecca. Thank you very much. It's a very interesting talk. My question is to try this tool, Go Please. I would need some editor that already support it on the other side, right?
Yeah.
Does this editor already exist? Like, is there like a custom plugin, for example, for the VS Code that supports it already?
So VS Code actually has an experimental feature for language servers. And so actually the main Go plugin for VS Code supports it. You just have to, basically there's a flag, it's in the wiki. You just say use language server as true, and then by default it will be Go Please. So instead of making our own plugins for the editors, we're communicating with the people who maintain the editor plugins, like Vim Go and VS Code Go, and we're basically just adding Go Please support that way. So that's basically how we're going to do it.
Right.
Yeah.
Thank you.
Of course.
Hi, Rebecca. Thanks for your talk. And I have a question. Do you have some like timeline when will be? It's not alpha, maybe beta and release. Do you have some estimations now or not?
Unfortunately, I can't give you a concrete date, but I guess I expect in the next few months things will become more solid, maybe beta in the next few months. I think we'll see, but I plan to be sending out emails and kind of updates when things are more official.
Hi. Hi, Rebecca. Thanks for the presentation. And you mentioned in the presentation that gopls has been created because standard Go tools were slow. And as I know, currently Go team is working on speeding up startup times, reducing startup times for standard Go tools. And how is this related to gopls? As I know, in the next Go release, standard Go tools will have much smaller startup times comparing to previous releases. For instance, much smaller, it's 5 times or 10 times smaller.
Yeah, we have a member of the Go team who's been working on making Go list faster, and that's basically because Go list is the tool that's underneath Go packages and basically like gives all the information. So yeah, we actually have a person who's working on making command Go work faster, and so that's basically just all going to be combined in making Go please faster, because if the Go command works faster, then same thing for Go please. Yeah.
Hi, Rebecca, on the right. Thank you very much for the interesting topic. I would like to ask, what happens with Guru, which was written by Alan Donovan, if I'm correct?
Yeah.
And are you planning to introduce some refactoring capabilities into the Go, please?
Yeah, so Guru is basically the original Go please. Yeah, it was basically a tool that has a lot of different features and works like on the command line. Basically, Go please is just the next iteration of Guru with caching. That's essentially what it is. We'll probably deprecate Guru in favor of Go please once it's ready, but I think there's still features that Guru has that aren't part of the language server protocol. So I guess we'll keep it around for those features. And yeah, we definitely intend to add more refactoring. So like the first thing that we'll start with is renaming, but hopefully later on we'll be able to add more interesting refactorings. It's definitely on our list of top priorities.
Hey Rebecca, thank you. I have been using Go package for my Go tool, and as you say, it's really hard to make tests for such tool. You have noticed that gopls have its own testing framework that makes it much more easy, and my question is, can I reuse it for my Go package-based tool to write tests easily?
Yeah, absolutely. That's a great question. We actually, so the testing framework we have is called Go Packages Test, and so it's like right in the same directory. And basically, it allows you to put some special comments in the file and basically have it run a command, and it's all based on the different positions in the file. So yeah, you can definitely check it out and use it, and we definitely recommend that you use it because it makes things a lot easier. And it does all the setup, it tests in Go path and tests in module mode. So yeah, Go Packages Test.
Thank you.
Yeah, no problem.
Let's do one last question. Okay, great. There are no last question. Oh, there is. Okay.
First, thank you for Go, please. I have 2 questions, actually. First, the only way to stop breaking editor each half year is to release Go, please, together with other Go tools. Do you plan to release it together, or it will release separately?
We still haven't figured out a process for releasing Go please. Right now, people are just using it from head, but I suppose we will eventually define some release process, and at that point, we'll probably solve that question.
Okay, and the second question, it's actually a bit technical. Clang, C++ library for parsing and indexing C++ has auto-completion support for editors, and Clang has feature unsaved files. It Editor which integrates libclang can report which unsaved files it has. So Clang always knows which files don't exist on file system or differs from file system, and can provide patches after completion with unsaved files. Does GopLease support passing unsaved files through language server protocol?
Yeah, so actually the language server protocol can send you an update every time your file changes, not just when it's saved. So yeah, GopLease should work fairly well with unsaved files. And
Thank you.
yeah, it basically updates everything once you type.